I'm going to do page 33 in your class notes, and this is example 11 on ground speed and direction of an airplane. An airplane has an airspeed of 550 kilometers per hour bearing north 30 degrees west. The wind velocity is 50 kilometers per hour in the direction of north 45 degrees east. Find the resultant vector representing the path of the plane relative to the ground. That's the first question. What is the ground speed of the plane and what is the direction? Okay, so let's draw this figure out first. Alright, so for my first one, I'm going to look at the airplane, and it has an airspeed of 550 kilometers per hour, so that's the magnitude, and then this is the bearing. So north 30 degrees west is the same thing as from the north going towards the west, right? So that's going to be 550, and so I'm going to be swinging over 30 degrees towards this way. Okay, so I'll call this as my v vector. And then I have a wind velocity that is 50 kilometers per hour in the direction of north 45 degrees east. So that's the wind velocity, and it's 50 kilometers per hour. So that means that it's going to be from the north going towards the east. So that's exactly halfway. And since it's 50, I'm just going to make it a little bit shorter. Okay, so that's your W. Alright, so I'll use the parallelogram method to figure out the resultant. And so I'm going to be creating a parallelogram like this. Okay, so my resultant is from the initial point here and then to the it's going to go to the diagonal, right? So this is very close. It's hard to tell whether it's in the first quadrant or the second quadrant, but once I calculate the algebraic method, then I'll be able to tell what that is. Okay, so this right here is my v plus w. Alright, so my v vector is going to equal magnitude of v times the cosine of theta, magnitude of v times the sine of theta. So then substituting my values in, this north 30 degrees west is going to be here, and so that is going to represent 120 degrees. Okay, so it's going to be 550 cosine of 120 degrees, 550 sine of 120 degrees. Okay, next I'll do the wind velocity vector. So W is equal to magnitude of W times the cosine of theta, magnitude of W times the sine of theta. So then W is going to equal 50, and for this one it's north 45 degrees east, so then that angle here is going to be just 45 degrees. Okay, so this right here is 45 degrees. Okay, so that'll be cosine of 45 degrees, and then you have 50 sine of 45 degrees. Alright, so to figure out what is the resultant vector, I'm just going to add them up together. So that'll be v plus w. So I'm taking my x component and adding it together, and my y component and adding it together, and you get an answer of negative 239.6447, and then 511.6693. Okay, so what this tells me is that it's going to be negative x component and positive y component, so it's going to be in quadrant 2. So this lands in quadrant 2. Right, so my diagram is slightly off, but I'll fix that when I redraw that. So now when you take the magnitude of that, v plus w, I take the x component, square it, y component, square it, add it together, and then take the square root. So I end up with 565.009 kilometers per hour. Okay, so that represents the ground speed. Alright, now to calculate the angle, I'm going to redraw that, and I'm going to put it a little bit more in the second quadrant. Okay, so when you're doing the drawing, sometimes it's going to be not as accurate, but this right here, when you're looking at the algebraic resultant, that is the accurate answer. Okay, so I'm going to make it go into the second quadrant just slightly, a little bit more. Alright, so right about here. So here's my v plus w. Okay, now I'm going to draw my x component and y component, create a right triangle out of that, and this is going to be my theta prime. Okay, so this right here is my x component, and I'm just going to use a positive value here, so that's 239.6447, and then my y component is going to be my 511, so it's 511.6693. Okay, so then my angle here, angle theta prime, right, so since I'm in the second quadrant, it has to be a theta prime. Theta prime is equal to the inverse tangent of, and then the opposite, so 511.6693, and then divide that by 239.6447. Okay, so for that one I get 64.904 degrees. Right, but the angle that I actually want is this, from here to here. This is actually the true angle. So to get theta, it would be 180 degrees, and then I'm going to subtract off theta prime. Okay, so that's going to be 180 degrees minus theta prime. So then the actual angle comes out to 115.096 degrees. So that is your theta.